Example 10.2. So you can see in this example, you need to design a combined footing. So actually the footing support two columns. First column with the dimension of 300 mm multiplied by 300 mm. So this is the square column, and then the second column is 400 by 400 mm. And then the self-bearing pressure, so means the bearing capacity or soil bearing capacity is 300 kilonewton per square meter, or we can call as 300 kPa, kilopascal. And then the FCK is 30 Newton per square mm, and FIK 500 Newton per square mm. And in this example, we assume a base thickness or the thickness of the footing is 850 mm. Okay, so based on prescriptive method, okay, we need to determine dimension of the footing based on the serviceability limit state. So first we need to determine the net self-bearing pressure, means the self-bearing pressure minus the self-weight of the footing. So here you can see 300 is 300 kPa minus 25 multiplied by h is the thickness of the footing. So 300 minus 25 multiplied by 0.85. So the net self-bearing pressure is 278.8 kilonewton per square meter. Okay, and also from the next slide on the figure, you can see the total load at the left side 100 plus 200, and the right side is 1400 plus 300. So the total load or total serviceability load is 2900 kilometers. So as already mentioned in the previous slide, so you can see here this the plan of the footing, the combined footing. So the left side is 300 by 300 mm column, the right side is 400 by 400 column. And then first we need to calculate the area of the base of the footing. Is the serviceability load 2900 divided by net self-bearing pressure 278.8 kPa. So from this the required area is 10.4 square meter. Okay, so and then we provide the rectangular base 4.6 multiplied by 2.3. You can see in this plan. So the total area is 10.58 square meter, is largest compared to 10.4 square meter. So this is the sufficient. Okay, and then you can see here the distance between two columns is 3 meter. Okay, 3 meters. And then the distance from the center line of the column to the edges of the left side of footing is 0.54 meter. And then the distance from the center line of the right column, the 400 by 400 column, 1.06 meter. Okay. Then the next step to calculate the resultant of the column load. You also can see in this slide the cross section of the footing. Okay, so for this time being, please ignore the number of the rebar here. Okay, and then you can see here the thickness is 850, and then at the column 300 by 300 we have the GK 1000 kilonewton, QK 2000 kilonewton, and at the right side for the column 400 by 400 we have the GK is 1400 kilonewton, and then QK 300 kilonewton. Okay, so first we need to determine the resultant of load. So now we have 2-point load here at the column 300 by 300 and column 400 by 400. So first we need to determine the location of the resultant load with the distance x bar from the right column. So we have the x bar is equal to 1200 multiplied by 3. So 1200 multiplied by 3, actually the total load at the left side of column 1000 plus 200, okay, multiply with the distance from the center line of the column, left column to the right column. Okay, so 3 meter, and then divided by the resultant load. Resultant load is the total load, so 1200 plus 1700, the total load applied to this footing. So that we have x bar is 1.24 measure from the center line of the right column to the position of the resultant load, 1.24. Okay. After that, calculate the bearing pressure at the ultimate limit state load by using the load combination 1. So for the column load, we have 1.35 safety factor for the GK. So 1.35 multiplied by 1000 plus 1.5 multiplied by 2000. So this from the left column. And then 1.35 multiplied by 1400 plus 1.5 multiplied by 300 is from the right column. So that we have the 1650 from the left column, and then 2340 kilonewton from the right column. So that the total ultimate column load is 3990 kilonewton. So by using this ULS, we need to determine the air pressure, okay, due to the ultimate load, ultimate limit state load. So we have the 3990 kilonewton divided by the actual area of footing, 4.6 multiplied by 2.3. So that we have the air pressure is 377 kilonewton per square meter. Okay, and then after that, by assuming effective depth is 790, so this in this example they assume, but in your calculation you need to calculate by yourself. Means the effective depth is the thickness of the footing minus diameter concrete cover minus diameter of main reinforcement bar. Okay, and then so in this example you can see, assuming D equals 790 mm for longitudinal bar and with a mean D, mean effective depth 780 mm for punching shear calculation. Okay, so at the column first, the column first, we can calculate the Prd maximum. So means the maximum shear resistance without reinforcement by using this equation, 0.5 UD multiplied by 0.6 multiplied by 1 minus FCK divided by 250 multiplied by FCK divided by 1.5. I think you're quite familiar with this equation for the shear resistance design.